Solving systems of linear equations, the substitution method, example 10.4. In this example, I have 3x plus y equal to 13 and 4x minus 5y equal to 30. And I don't have one of the equations already solved for one of the variables, so I'm going to have to do that work. Now my eyes are going to that first equation and they're going to this y, because when I solve for y, I won't have to divide by anything at the end. If I used this equation and I solved for x, I'd have to divide that by 3 and I'd end up with some kind of fraction, and the same thing if I even went to any of those variables in the second equation. So I'm going to first take this equation 3x plus y equal to 13, and I'm going to just subtract 3x from both sides. So if I do that, all right, there's no x on the other side here, so essentially I'm just transposing. I end up with y equal to 13 minus 3x, or if you had put the 3x term first, it would have been negative 3x plus 13. All right, so I have y equal to 13 minus 3x, and the other equation remains 4x minus 5y equal to 30. So what I'm going to do is I'm going to substitute this expression into the second equation where I see the y. Doing that, I have 4x minus 5 times y. And I like to always use parentheses because you often have to distribute, as you will have to in this example. And those parentheses remind me that I need to do that. So opening these parentheses, I'm going to multiply everything inside there by negative 5. That's 4x minus 65 plus 15x equal to 30. Combining like terms, 19x minus 65 equal to 30. Adding 65 to both sides, I have 19x equal to 95. Dividing both sides by 19, x is equal to 5. Now, remember what y was. We solved y to be 13 minus 3x. So that's 13 minus 3 times 5, or 13 minus 15, which is negative 2. So the ordered pair 5, negative 2 is the solution to the system.